Sri Gurubhyo Nama children, welcome to online project Ekalaiva. Already we are discussing about the colloids. In the previous slide I told about the electrophoresis, that is the movement of the colloidal particles towards the oppositely charged electrode under the influence of the electric field. Depending upon the movement of the colloidal particles towards the oppositely charged electrode, we can assign the charge of the colloidal particles. If it is positive, they have moved towards the negative terminal. If they are negative, they have moved towards the positive terminal. So, depending upon their movement, we have talked about the charge of the colloidal particles. Here, we are going to see another important procedure, another important concept, which is nothing but electro osmosis. In both the cases, we are going to pass electric current. There is a difference between electrophoresis and electro osmosis. In the previous case, on passing current, the colloidal particles started to move. The dispersion medium is fixed. The dispersion medium is fixed, whereas the dispersed phase is moving. Whereas in case of electro osmosis, what we are going to discuss now, the dispersion medium will be moving, whereas the dispersed phase is stationary. So there are two different phases already I told you in a colloid. So there is a dispersed phase and dispersion medium. So in the previous case, electrophoresis, dispersion medium is fixed, it is not moving, whereas the dispersed phase is moving, the colloidal particles are moving towards the oppositely charged electrode. In electro osmosis, we are going to say the dispersed phase is fixed, where the dispersion medium will be moving towards the oppositely charged electrode. So we are going to talk about electro osmosis now. So this slide completely talks about the electro osmosis. On placing the colloidal solution, under the influence of electric field. Again, what we are doing, the colloidal solution is placed under the influence of the electric field. The particles of the dispersion medium move towards oppositely charged electrodes. In previous case, the particles of the colloidal particles, the particles in the dispersed phase, they started to move towards the oppositely charged electrode. Here in this slide, we are going to see a different concept. Here the dispersed phase is stationary. What is moving here? Actually the dispersion medium is moving. So the particles are the charges, the particles of the dispersion medium, they will be moving towards the oppositely charged electrodes. So it provides the colloidal particles. So provided the colloidal particles are not allowed to move. So here colloidal particles, that is dispersed phase, is fixed. The colloidal particles are not moving, whereas the particles of the dispersion medium, they are moving towards the oppositely charged electrode by applying electric potential. So we can call such a phenomenon is called as electro osmosis. So actually what is that, we are taking electrodes are taken here, and this is the colloidal particle which is fixed. So these are the colloidal particles which are fixed. Colloidal particles which are fixed. Colloidal particles, they are fixed, they are not moving, they are fixed. Whereas the particles in the dispersion medium, here the particles in the dispersion medium, they will be moving towards the oppositely charged electrode. As a result, here the dispersed phase is stationary, whereas the dispersion medium is moving. So this process is known as electro osmosis. So the next one, coagulation or precipitation. The stability of lyophobic colloid, already I told you, lyophobic colloid, we are discussing very much about lyophobic colloid. So the stability of lyophobic colloid is due to the presence of charge on the colloidal particles. How lyophobic colloids are having stability, how they acquire stability? Because of the presence of the charge on the colloidal particles. So lyophobic colloids, they are solvent hating colloids, they are unstable. How they are getting stability? Because of the presence of the charged particles because of the presence of the charge on the colloidal particles, they are acquiring stability. So if somehow the charge is removed, because of the presence of the charge, it acquires stability. If we are going to remove the charge, the particle will come closer. So what is happening there? If we are going to remove the charge, what will happen? The particles will be coming closer, so they will form aggregates and settle down under the force of gravity. As long as the charge is there on the colloidal particles, it will acquire stability. When we are going to remove the charge from the colloidal particles, what is happening? Mutual coagulation is taking place. The particles are associated together. The particles are coming together. They will form aggregates and they started to settle down under the force of gravity. This process of settling of colloidal particles is called coagulation or precipitation. So what we are doing? We are converting a colloid into precipitate. So what is coagulation? What is coagulation? The process of converting a colloid into a precipitate. The process of converting colloid into a precipitate. The process of converting a colloid into a precipitate is called coagulation. As long as the charge is present there on the colloidal particles, it acquires stability. When we are going to remove the charge from the colloidal particles, so what is happening? Mutual coagulation is taking place. Association of the particle is taking place. So the particle starts to settle down under the force of gravity. This process of settling of colloidal particles is called coagulation, or we can call it as precipitation. Because of the presence of the charge, it acquires stability. If we are going to remove the charge, what will happen? The particles come closer. They will form aggregates. As a result, the particles start to settle down under the force of gravity. This process of settling down of particles, we can call it as coagulation. So what is coagulation? The process of converting a colloid into a precipitate. Here what we are doing? We are converting a colloid into a precipitate. So here actually humic acid, so when they are added to neutral iron hydroxide flux, so what is happening? It forms a colloid. So what is happening here? Mutual coagulation is taking place, absorption of ions, the ions are coming closer, so you will be, colloids are converted into a precipitate. So we can call it as coagulation. The coagulation of lyophobic colloids. So lyophobic colloids, how they are coagulated? There are three different methods. One is electrophoresis, already I told you. One is electrophoresis. One is electrophoresis, other one is mutual coagulation, third one is by boiling. So lyophobic colloids, how they are, how coagulation is caused in case of lyophobic colloids. So we can talk about three different methods. Lyophobic colloids can be coagulated, that is, lyophobic colloids are those which are solvent hating colloids, they are unstable. So what we are doing? We are going to follow these techniques for coagulation of lyophobic colloids, association, aggregation of particles in the lyophobic colloids. First one is electrophoresis, already I told you. What is electrophoresis? The movement of colloidal particles towards the oppositely charged electrode by passing current. Already we have seen this experiment. So when we pass electric current between the two platinum electrodes which is kept immersed in the dispersion medium, I already told you on passing current what is happening? The colloidal particles are moving towards the oppositely charged electrode. When they are positive, they will move towards the negative side. When they are negative, they will move towards the positive side. So based on this, it will acquire charge. Similarly, there is another way of coagulation, mutual coagulation. What is that? Oppositely charged salts, when mixed in almost equal proportion, neutralize their charges and get partially or completely precipitated. So oppositely charged colloidal solutions are mixed together in equal proportions. So oppositely charged colloidal solutions are mixed together in equal proportion. What is happening? Mutual coagulation is taking place, attraction is taking place, neutralization is taking place. The next one is boiling. When a solution is boiled, the adsorbed layer is disturbed due to the increased collusions. The adsorbed layer that is at the surface. So the adsorbed layer that is present at the surface of the colloidal solution gets disturbed. It is greatly disturbed when we boil the colloidal solution. So what is happening with the molecules of the dispersion medium? So what will happen? The particles that are present at the surface of the colloidal solution, it gets, so it will lead to so many collusions. It will be collided. Those particles, it gets collided with the particles of the dispersion medium. Therefore, this reduces the charge on the particles and ultimately leads to the settling down in the form of a precipitate. So here actually what is happening? The colloidal particles are present at the surface. So what is happening here? By boiling, what we are doing? We are disturbing the particles at the surface of the, at the surface of the adsorbent. So what is happening here? The collusions will be increased. Because of the increased collusions of the colloidal particles with the particles in the dispersion medium, what is happening? Coagulation is taking place, association is taking place, aggregation is taking place. Thereby the colloids are converted into a precipitate. So these are the three methods where lyophobic colloids undergo coagulation. The first one is electrophoresis, that is by passing current, what is happening? The particles are moving towards the oppositely charged electrode, mutual coagulation is taking place. The next one is I already told you, when oppositely charged colloidal solutions are mixed in equal proportion, what is happening? Neutralization is taking place, thereby colloids are converted into a precipitate. The next one is by boiling. So when you are boiling the colloidal solution, what is happening? At the surface, what is the particles which are present at the surface is greatly disturbed. How? As we are boiling the colloidal solution, number of collusions will be greater at the surface. So the particles which are present at the surface of the colloidal solution, it gets collide with it gets bombarded with the particles in the dispersion medium. As a result, what is happening? The charge on the surface of the particle is getting reduced. As a result, mutual coagulation is taking place, association of particles are taking place. So by this method also we can convert a colloid into a precipitate. So all these methods are completely talking about the, what is that? Coagulation of the lyophobic colloids. Coagulation, already I told you, converting a colloid into a precipitate. Then based on this we are going to talk about one important rule. What is that? Hardy-School's rule. So based on the, what is that, coagulating power, based on the coagulation, based on the aggregation of particles, we are going to talk about one important concept. What is that actually? Hardy-School's rule. So based on that we are going to talk about an important concept based on the coagulating power. So we can call it as Hardy-School's rule. So actually the greater the valency of the flocculating ion added, precipitating ion, flocculating is nothing but precipitating ion, greater the valence of the flocculating ion added, greater will be its power to cause precipitation. This is known as Hardy-School's rule actually. What do you mean by flocculating? Precipitating ion. Flocculating is nothing but precipitating ion. The ion that causes precipitation. So greater the valency of the flocculating ion, precipitating ion, greater will be the power to cause precipitation. So when the valency of the precipitating ion is greater, what is happening? The precipitation is also greater. So we can call this rule as, what is that? Hardy-School's rule. So in the coagulation of negative sol, so if it is a negative sol, what is that? We have the flocculating power is in the order of, what is that? Aluminium 3 plus, see that Al 3 plus. So 3 positive charges. What about the barium 2 plus? It has got 2 positive charges. And similarly sodium plus, it has got only 1 positive charge. So here, depending upon the valency of the precipitating ion, the greater will be the power of precipitation, flocculation or precipitation. So we can call it as Hardy School's rule. Particularly in the coagulation of negative salt, if it is a negative salt, we will be adding the positively charged particle, is it not? We are going to add the positively charged particle. So when you are comparing the precipitation power, precipitating power of the positively charged particles, greater the valency of the precipitating ion, greater will be the precipitation. For example, I have taken three important ions here: aluminum ion, barium ion and sodium ion. See, aluminum ion, it has got three positive charges, so it will have a greater precipitating power when compared to barium, which has got two positive charge, and sodium, which has got only one positive charge. In the coagulation of positive salt, if it is a positive salt, what we will do? We will add the negatively charged particle, is it not? The flocculating power is in the order of FeCN6 4 minus actually. So FeCN6 4 minus, which is greater than PO4 3 minus, which is greater than SO4 2 minus, which is greater than Cl minus. So here, what is that? FeCN6 4 minus. So it has got 4 negative charges. So it will be greater than PO4 3 minus, which will be greater than SO4 2 minus, and which will be greater than Cl minus. See here, the negative charge, see the negative charge, greater the, what is that, valency of the positive or negatively charged ion, greater will be the precipitation. So this is, what is that, Hardy School's rule. So depending upon the, what is that, valency of the flocculating ion, we can talk about the precipitation of the particular colloidal solution. So here we have talked about the positive salt. When it is a positive salt, we are adding the negatively charged particle. So whether it is a positively charged or negatively charged particle, what we have to see? We have to see the valency of the charged particle. Greater the valency, greater will be the precipitation. So in case of positive salt, I am adding negatively charged particle. So when you are comparing the, what is the precipitating power or flocculating power of negatively charged particle, potassium ferrocyanide, that is ferrocyanide ion, which has got a 4 negative charges, is greater than phosphate ion, which is having only 3 negative charges, which is much greater than sulfate ion, which has got only 2 negative charges. Sulfate ion is greater than chloride ion, which has got only 1 negative charge. When it is a negative salt, we are going to add a positively charged particle. Even in the case of positively charged particle, you have to see the valency of the positively charged ion. So I have compared 3 different ions. One is aluminum, the other one is barium, the third one is sodium. So aluminum being a, what is the 3 positive charges, it will have a greater power of precipitation when compared to barium, which has got only 2 positive charge, and which is very greater when compared to sodium, which has got only 1 positive charge. So depending upon the valency of the precipitating ion, we can talk about the extent of precipitation. So for a negatively charged solution, I am adding a positively charged particle. So see the charge of the positively charged particle. When the charge is greater, the extent of precipitation is also greater. So in case of aluminum, barium and sodium, aluminum is having 3 positive charge, so it will have a greater precipitating power when compared to barium and sodium. For a positively charged solution, I am adding a negatively charged particle. Even in the case of negatively charged ion, we have to see the valency. The greater the valency of the negatively charged ion, greater will be the extent of precipitation. So in case of negatively charged ion, we have compared ferrocyanide ion with phosphate ion, sulfate ion and chloride ion. Ferrocyanide ion has got 4 negative charges. The greater the number of charges, greater will be the precipitation. There are 4 negative charges, which is greater than phosphate ion, which has got only 3 negative charges, which is greater than sulfate ion, which has got only 2 negative charges, and which is greater than chloride ion, which has got only 1 negative charge. So this rule we can call it as Hardy School's rule. So Hardy School's rule talks about the extent of precipitation based on the valency of the precipitating ion. The minimum concentration of an electrolyte in millimoles per liter. the minimum concentration of the electron millimoles per required to cause precipitation of a solution in 2 hours is called coagulating value, the minimum concentration of an electrolyte. So we are going to add an electrolyte, is it not? The minimum concentration of an electrolyte in millimoles per liter. So how much we are adding? Only the minimum concentration, that is millimoles per liter we are adding, which is required to cause precipitation. So we can call it as coagulating value or precipitating value. Smaller the quantity needed, higher will be the coagulating power of an ion. We are going to add only small concentration of the electrolyte. So as we are going to add only a smaller quantity of the electrolyte, higher will be the coagulating power. So when you are going to add the electrolyte to cause precipitation, we have to add only a small quantity of electrolyte. So if you are going to add small quantity of the electrolyte, greater will be the coagulating power or precipitating power of an ion. So here actually negatively charged particle with cloud of counter ions. So here negatively charged particles are there. So which is, what is that negative? This is negatively charged particle. So it attracts the counter ion. So counter ion is positive here. So aluminum 3 plus. So what is that? It is a negative sol. It is a negative sol. So what is that I am adding here? For precipitation, I am adding a positively charged particle. So here when we are going to add aluminum 3 plus, add strongly absorbing species of opposite charge. So strongly absorbed. So aluminum is having a greater charge, 3 plus charge. So I am adding aluminum ion over the negatively charged sol. What is taking place? Neutralization is taking place. What is that? Neutralization is taking place. Coagulation is taking place. Precipitation is taking place here. Neutralized particle with no double layer. See, there is no double layer. So mutual coagulation is taking place. We have converted the colloid into a precipitate. So this slide talks about a negative sol where we are adding the higher charge, that is higher charged particle, positively charged particle, that is aluminum 3 plus. So what is happening here? They are coming closer. So what is that? Mutual coagulation is taking place, which leads to the precipitation of the colloidal particles. So colloidal particles are converted into a precipitate here. So up to this we have discussed about the Hardy School's rule, which talked about the coagulating power, flocculating power of the colloidal solution by adding either a positively charged particle or negatively charged particle. Up to this I am concluding today, children. We will see the rest of the concepts in the next class. Thank you, children.